In this video, we're going to address solving quadratics, and we learned 4 method for solving, and this box is just for your reference to think about which you might do in each scenario. So if we're thinking about the easiest way to solve quadratics, we would always look for inverse operations first, and this is the same as saying we're going to take the square root of both sides. We would do that when we have an x squared in our equation with no bx term, no term with just an x. Additionally, we might do this if we see our equation in vertex form, where we have parentheses squared, and would be able to get that as the parentheses squared equal to a number, so we could take the square root. If we can't take the square root, the next thing you would think about would be factoring. So we can kind of put these in order. Factoring would be the second choice. We would do that if we have a quadratic trinomial where we can solve our x puzzle or our cross. We would factor if we see a difference of squares. We would factor if we saw 4 terms that we cannot combine. And the key with factoring, if we decide that that's our method, once we decide we're going to do that, our equation must be equal to 0. If we cannot factor, then we would think about completing the square. That would be our third choice, and we would use that if we cannot factor, can't figure out that cross, or it's not a special pattern, and our a value is 1 and our b value is even. So we want to make sure we meet those criteria before we complete the square. And if we cannot do any of the first 3, then we'll go to the quadratic formula, and we will use that for any quadratic trinomial that cannot factor and isn't good for completing the square. And as a reminder, if we're going to use the quadratic formula, again, our equation must be equal to 0. And just a note here on factoring, a difference of squares could also be square roots if you wanted to. So there are a couple of good choices for difference of squares. It is easy to factor, but it's also easy to take the square root. So you can make the choice that makes you feel most comfortable. If we go to the next page, we'll see 4 where we're told how to solve, just as a reminder, and then 4 where we get to choose. 17, solving by square roots are inverse operations. If we're going to do that, our squared term must be isolated first. So we need to get that set of parentheses that is squared all by itself first. We're going to add 3 to both sides. Then we are going to multiply both sides by 5 to get rid of that fraction in front. And we get negative 35. Now that the squared term is alone, we can take the square root of both sides. Every time we take the square root, we have to remember to put a plus or minus in front. So I'm going to do that in my next step. If I can get this pen to work again. There we go. Now, there are 2 things we have to do to simplify. We have to recognize that there is a negative underneath our radical, which makes our answer imaginary. And of course, we're not solved until our x is completely alone, so we need to add 8 to both sides of this final equation And there is our final answer. Two answers because of the plus or the minus. 18 tells us we're going to solve by factoring. So we'd look for a greatest common factor first, and we can't find one. Our a value is equal to 12, so we're going to use a cross and a box. You can use your factoring flowchart if that helps. Within our cross, a times c would give us 12, 12 times 1. And we're looking for factors of 12 that add to negative 7, and that can be done with negative 3 and negative 4. That's going to help us fill in our box. 12c squared and 1 in the corners, negative 3c and negative 4c in the other corners. Order doesn't matter. And then we factor up and we factor over, looking for greatest common factor. 12c squared and negative 4c have a 4c in common. 3c and 1 don't appear to have anything in common, so we're going to call that minus 1, a negative because it's next to a negative. Going across the top, 12c squared and negative 3c have a 3c in common. Negative 4c and 1 don't really have anything, so we put a 1 there. And again, that will be negative because it's next to a negative. Now, the factors are just a starting point. Now we have 4c minus 1 times 3c minus 1 and equal to 0. It was at the beginning, so we didn't have to change anything there. And when our factors are equal to 0, we're going to split them, set each factor equal to 0, and solve. So we'll add 1 for the factor on the left, and then we'll divide by 4, so c is 1/4. And on the right, we'll add 1 and divide by 3. So our two answers are 1/4 and 1/3 by factoring. Number 19, we're being told we're going to use the quadratic formula, so no need to worry about the other methods. We do know if we're going to use the quadratic formula, it must be equal to 0. And the quickest way to do that is to subtract 3m squared from both sides here. There's our 0. Now we want to put our terms in standard form, so I'm going to put the negative 3m squared first, then 8m, and then minus 3. And when we go to fill in our quadratic formula, our a value is negative 3, our b value is positive 8, and our c value is negative 3. For your reference, the quadratic formula looks like this that I'm writing on the screen right now. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So as we fill that in for our problem, we're going to have negative in front of the 8 plus or minus an 8 squared minus 4 times negative 3 times negative 3. That's all over 2 times negative 3. So now we need to simplify inside the radical. I'll start with that 8 squared, that's 64. Then we're going to multiply 4 times 3 times 3. And there are 3 negatives there. So I know that we'll be getting a negative when we multiply those 3 terms together, and that will be minus 36. And that's all over 2 times negative 3, so I'm going to call that negative 6. Now we're going to subtract underneath the radical. 64 minus 36 would give us 28 over negative 6. And because we are good mathematicians, we're going to think about factors of 28, and we'd prefer 4 and 7 because 4 is a perfect square. And we're going to take the square root of 4 and bring it to the outside. And now we need to simplify our fractions because negative 8, negative 6, and 2 and negative 6 all have a 2 in common. So I think the best way to do that is to write this as 2 separate fractions. The negative 8 gets divided by negative 6, and then the 2 root 7 also gets divided by negative 6. Negative 8 over negative 6 would give us 4/3. 2 over negative 6 would give us 1/3. And if you wish, you can write that as a single fraction, plus 4 plus or minus root 7 over 3. So either as 2 fractions or as one fraction because they have a common denominator. In problem 20, we are going to complete the square. And when we complete the square, this is our number that we don't care for. We're going to decide what number we would like to add to our two variable terms. So we're going to start by moving that 5 over to the other side of the equation. And I'm going to leave some space there because the goal of completing the square is to decide what we want to add to make that quadratic factor the way we want. And we're going to work with d squared and 18d in our box. And remember, we start by putting the d squared or the squared term in the corner, and then we split the 18d into two parts, even parts, 9d and 9d. And we know now that our factor is going to be d plus 9 and d plus 9. That tells us that in order to factor the way we want, our bottom corner would be 9 times 9, or 81. So we add that to both sides because we're dealing with an equation. Then when we rewrite what we have, d squared plus 18d plus 81, and negative 5 plus 81 is 76. d squared plus 18d plus 81 is exactly what we have in our box, so we know that it factors as d plus 9 squared. And we're now at the point where we can take the square root of both sides, d plus 9 on the left, and we're going to do plus or minus the square root of 76 on the right. We need to simplify our square root. So 76 is 4 times 19, and the square root of 4 is 2. And now to solve our equation for d, we're going to subtract 9 from both sides. To get our final answer. So that is completing the square. If we go to the next page, we'll see 4 problems where we are to solve with the most efficient method. And we'll run down each of those in order to determine how we want to solve each of these equations. But again, you have choices. The one thing that will work on all of them is completing the square if it's in standard form. Let's look at 21. My first question would be, could I take square roots? And I cannot because there is an x term. The negative 6x tells me I cannot take a square root. So then I'm going to ask, can we factor? I'm going to make a cross and ask, are there factors of 8 that add to negative 6? And we can solve that with negative 4 and negative 2. So factoring would be quite efficient. Our two factors have already been decided, x minus 4 and x minus 2, and we are already equal to 0. So we'll set each factor equal to 0 and solve to get our two solutions, 4 and 2. If I look at number 22, this appears to be in vertex form. I can see something squared and only numbers around it. So I think using inverse operations or square roots would be most efficient. But in order to use square roots, we need to get the squared term all by itself first. So we're going to add 4 to both sides, which gives us 16. We're going to divide by 2 then. And once the squared term is alone with just a number on the other side, we're going to take the square root. Leaves us with x minus 3, and of course we'll put plus or minus root 8 on the other side. We're going to think about simplifying 8 because it is 4 times 2. So we want to take the square root of 4 and bring that to the outside for 2 root 2. And now our last step, if we have x minus 3 equals plus or minus 2 root 2, I just rewrote that same last step, would be to add 3 to both sides for our final answer. So factoring for the first one, square roots for 22, the second one. Going on to number 3, this is a quadratic trinomial. I cannot take square roots, but perhaps I can factor. So I'm going to make my x and test that out. Can I find factors of positive 10 that add to negative 8? Factors of 10 would be 1 and 10. Those cannot combine to 8. 2 and 5 are other factors of 10, and those cannot combine to 8. So I cannot factor. No square roots, no factoring. Then we're going to think about completing the square. The a value is 1. The b value of negative 8 is even. So completing the square should be a good way to solve this quadratic. When we complete the square, it's the 10 that keeps us from factoring, so we're going to move that to the other side of the equation and leave some space because we are going to decide what we want to add to make it factor as a perfect square. We're going to put x squared in the corner. We're going to split negative 8 into 2 equal parts, negative 4x and negative 4x. So we know our factors will be x minus 4 and x minus 4. Once we decide those factors, negative 4 times negative 4 tells us we should add 16 to both sides. So go ahead and do that. That leaves us with x squared minus 8x plus 16 on the left. And on the right, negative 10 plus 16 is 6. Because we added the 16, we know that the left-hand side factors, like the box shows us, x minus 4 squared equals 6. And now we can take the square root of both sides. Putting a plus or minus in front of that root 6. 6 only breaks down to 3 and 2. It doesn't have any perfect square factors, so we will just add the 4 over. And those are our final answers. For 24, I would probably first think about factoring because we cannot take square roots. And again, doing a times c because there's no greatest common factor. 3 times negative 5 would be negative 15. And we have to find factors of negative 15 that add to negative 4. 1 and 15 are possibilities, but those will not add to 4. 3 and 5 are other possibilities. Those will not add to 4. So we cannot factor. The a value is 3. That means I do not want to complete the square. So we're going to go with our final option, quadratic formula. When we do that, use the quadratic formula. Our quadratic trinomial has to be equal to 0. It is already. So that means our a value will be 3, our b value will be negative 4, and our c value will be negative 5 as we plug that in. We wrote it earlier, so I'm not going to repeat that. You can write it on your note card. You should write it on your note card so that you can have it for reference. And I'm going to go straight to filling that in. X equals the opposite of b plus or minus the square root of b squared. Notice how I'm using parentheses. Minus 4 times a times c all over 2a. And now we're going to simplify underneath our radical. Outside the radical first, I see the opposite of negative 4, so we'll just call that 4. We will square negative 4, which is positive 16. And then we have negative 4 times 3 times negative 5. There are two negatives, so whatever we get will be positive. You can use your little calculator to do that. I'm going to do 4 times 5 first, which is 20. And then we multiply 20 by 3, which is 60. And this is all over 6. And we're going to add now underneath our radical 16 and 60 to give us 76 all over 6. We want to simplify our radical. You can check out 76 with your little calculator, divide it by perfect squares, and we will find that 4 is a factor, 4 times 19. So we're going to take the square root of 4, which is 2, bring it to the outside. And now I'm going to write this as 2 separate fractions. So that we can simplify. 4 over 6 is 2/3. 2 over 6 is 1/3. So we can write our answer as 2/3 plus root 19 over 3, or we could write 2 plus or minus root 19 all over 3. So if it helps you to split it into two fractions to simplify to do that, you can also just remember, going back a step here, that if we look at our three terms and we see a 4, a 2, and a 6, we can just divide those all by 2 and get to our final answer. And last but not least, some error analysis. Dennis says that the equation x squared plus 8x equals 4 can be solved with the quadratic formula where a is 1, b is 8, and c is positive 4. Sophie says that the correct coefficients for this equation would be a equals 1, b equals 8, and c equals negative 4. Who is correct? And explain your answer. So we are solving with the quadratic formula. So let's consider our equation. If we're going to use the quadratic formula, we must be equal to 0 before we use it. And as written, we are not equal to 0. So first we would subtract 4 from both sides. And then we could say our a value is 1, our b value is positive 8, and our c value is negative 4. So that means Sophie is correct. The quadratic trinomial must be equal to 0 before using the quadratic formula. That means Dennis did not have the equation equal to 0. So he was incorrect.